What will happen if we treat a pyrrole with this kind of group in presence of phosphorus oxychloride, and just for these things for workup purposes, we get these products. This is Vilsmeier reactions. Now, in the later discussion, we will discuss or we will have a put a closer look why this rearrangement go, what is the driving force for this rearrangement. So let us have a closer look or critical look on the mechanistic pathway. So first step, what will happen? So we know normally this kind of delocalization takes place here. O minus A raised to. Look, here one fantastic phenomenon takes place. This is double bond O, NH2. As this delocalizes like electronic push, and we have POCl3. POCl3. And oxygen has some fantastic desire towards phosphorus. Because those electronics push, so this negative charge will not be just staying with this oxygen. So it will go to, oxygen will link to the phosphorus. And when it will be come back, this Cl will leave. As a result, we'll have intermediate. These things. P. See how much is interesting. Here it stops here, but in case as we have the phosphorus that has good tendency towards oxygen, now this oxygen will link to this phosphorus. This is the first driving force. First driving force. Otherwise, it won't react with this and form this new intermediate. The first driving force is what? The tendency or good desire or good relationship, good friendship between phosphorus and oxygen. This is first driving force towards good friendship between oxygen and phosphorus. So what we have? We have these things now. This is P double bond O Cl2 NH2 plus, and we have Cl minus. Now these moieties wants oxygen alone together, means these don't, because they are strong desire. So this no longer allow this oxygen with these other groups. So now this will attack here the Cl minus that leaves. We can say the Cl minus, and this will go away. So what we have these things now are, this is Cl, this is, yeah. So this is a iminium cation. Iminium cation. Now we'll see what happens for this iminium cation. What are the fate of this iminium cation? So go to the next page. So now we have iminium cation ready. Cl is to plus, and we have this pyrrole. For pyrrole, what happens? This kind of delocalize inside the ring will attack here. So as a result, what we have this kind of things. C NH2 plus and This is NH plus, and minus H plus, it will regain the aromaticity. C double bond H R, NH2 plus. This is iminium cation. Iminium cation. Here we will try to find the driving force, second driving force for the reaction. First driving force, we have pointed out there is a strong desire of phosphorus to our oxygens. Second driving force is that we had iminium salt. This is iminium cations. Iminium cation, and this is, sorry, this is iminium cation. This is iminium salt. Iminium salt. Look, iminium salt is more stable than iminium cation because this take part in delocalization in the ring because of the extended delocalization. So it is stabilized by the ring pi electrons also. That's why iminium cation. So now it is iminium cations. It is going to be part of ring and being iminium salt. Its stability increases. That's why it's incorporate or it become installed in the ring. So this is the second driving force, that iminium salt is more stable than iminium cation because of two driving force. This is the second driving force. The reaction proceeds and the Vilsmeier reaction happens because the C double bond NH2 part gets stabilized by pyrrole pi electron or pyrrole pi system. Now we have this thing ready, and upon hydrolysis, it will form this. NH2 plus R. Just we see, we remember in the second step we use sodium bicarbonate and H2O. This is the workup step, and after workup we will have this. So we have read the Vilsmeier reaction initially, but here the two things, main things we learn, that why this reaction proceed, what is the driving force for the reaction. Two driving force: number one, the strong PO bond; number two, the in situ generated iminium cation is less stable than the iminium salt. So it will try to go into such a state where it will be more stable. That's why it become a part of pyrrole ring and the reaction proceed. And why iminium salt is more stable? Because this now systems is be a part of this total conjugated systems. That's the main driving force for these reactions.